Okay, I'm back. I'll put this on the other screen to begin. And I will share my screen, the one on which I will do my work. And then I will check the audio to make sure that it's coming through. Test. Okay, it's coming through. So let's begin. We are to solve each inequality and graph its solution. These are absolute value inequalities. So what does this first one say? This says the absolute value of 6n is less than or equal to 18. Now, when is that true? When is that true? So if this was just a regular inequality, like this, 6n is less than or equal to 18, of course, the solution would be n is less than or equal to 3. We would put a little colored dot, filled in dot underneath. Everything would be fine. But this involves the absolute value of 6n. So let's think. If I were to input -5 where n is, would that be valid? It's valid over here because 6 times -5 is -30, and -30 is indeed less than or equal to 18. But what about over here? For the absolute value one, 6 times -5 is -30, and the absolute value of that is 30, and that is not less than or equal to 18. So, what do we do? Well, long story short for this one, I mean, we go from 3 to -3 like that. And what's the best way to think about it? Okay, and when they say solve the inequality, they really mean this. I think so. Let's just double check for the first one. Okay, that's how they want it on the number line itself. And indeed, they do want that sort of inequality expressed like that. -3 is less than or equal to n, which is less than or equal to 3 itself. Okay, but what's the way to think about it? The way to think about it is, in this case, that we want to know when is something less than or equal to 18 in its size, overall size. So imagine, yes, this is the way. Think of this. Then divide both sides by 3, and we get the answer. Okay. What about this one here? Absolute value of p at 4 is less than or equal to 8. Okay, so solving it like a regular inequality, the answer would be p is less than or equal to 4. So I will do my sort of graph underneath it. P is less than or equal to 4. And so you would go sort of like that. But using the technique that I just talked about, let's see if that works. And take 4 from both. Okay, well, let's see. Well, -12 add 4. Well, that's -8, and the absolute value of -8 is 8, and 8 is indeed less than or equal to 8. So that works. And if we were to just go a little bit further into the negatives, like -12.1, then it wouldn't work. Okay, so that works for this. Not so bad. All right. But we want to graph it accurately. So we'll place the filled in dot underneath 4 and the filled in dot underneath 12 and connect them like that. Next, the absolute value of m take 2 is less than 8. Okay, so -8 is less than m take 2, which is less than 8. Plus 2 to both sides, or all three pieces. And -6 is less than m, which is less than 10. Dot under there, dot under there. One more, and then we check that everything's going well. The absolute value of 5x is less than or equal to 10. Okay. -10 is trapped between 5x is trapped between -10 and +10. And therefore, x itself is trapped between -2 and +2 inclusive. So a dot underneath 2 and a dot underneath -2, and then connect them up. All right. Now, did I solve all of these? Okay. The solution should be written down somewhere. There's the solution for the first one. For the second one. And the fourth. But not the third. It should be written down. -6 is less than m, which is less than 10. Now to check. Good for the second. Good for the third and fourth. All right. Fifth one then. The absolute value of x plus 5 is greater than or equal to 11. Okay? Take 6 from both sides. Absolute x is greater than or equal to 6. Trap the value of x. 6. Make it go the right way. Put the negative on the left. The x in the middle. Okay, like that. And here. Mm-hmm. Oh, yes. Okay. So I see. Right. There's a mistake here then. It should be hollow. Like that. Yes, this should be hollow as well. That's an error. You should always fix any errors. Right. Eighth one. Take 3 from both sides. Pincer it between -3 and 3. No. Check. Make sure that we're on track. Okay. Question 5. Wrong. Okay, these ones are totally wrong. Need to figure out why they're wrong though. The absolute value is difficult. Okay, so I think I understand. Not think about it so programmatically, but like logically. If the absolute value of x is greater than or equal to 6, then linear equation, that would just be saying x is greater than or equal to 6. So it'd be everything over here. But then I have to just pay attention to the magnitude of the quantity involved and just sign completely. So -8 would also be in the club. So that would be included as well. Okay. I think I understand this now. But how to write this? Right, x is less than or equal to -6, and x is greater than or equal to 6. Let's see this one. The absolute value of m is greater than 2. Okay, so it'd basically be the opposite of that. That's better. Okay. Next, the absolute value of r is greater than 1. Think about it logically. Of course, 2 would be included. And of course, -2 would be included. So similar to graphing inequalities, I think I should test the actual final answer. Yes. Okay. Should be a complete opposite as well. This is what I'm going to be all about here. Finding my weaknesses and fixing them. And the only way to do that is to be thorough. And turn over every stone. Okay. The absolute value of x minus 2, that is less than negative 2. Okay, so I think I can just add 7 to both, add 5 to both sides. So the absolute value of x take 2 . So x take 2 is trapped between 3 and minus. So x is between negative 1 and 5 exclusive. Okay, we're back on track. Not so bad. Right. Add 5 to both sides. Absolute of x take 4 is less than 8. So it must be trapped between minus 8 and 8. What's going to be trapped between minus 8 and 8? X take 4, so add 4 to both sides. Do it in your mind. Negative 4. X. 12. Like that. Absolute of 1 plus b is less than 3. So trap it between 1 add b, it's between negative 3 and 3. Trap 1 add b between there. Negative 4 is less than b, which is less than 2. Okay. Add 6 to both, add 6 to both sides. So absolute of v add 5 is less than 1. So it's trapped between negative 1 and 1. V add 5 is trapped between them. So v is trapped between negative 6 and negative 4 exclusive. Okay, time to check. Right. Nine. Okay, valid. Moving on. Okay, so as a linear 10p take 4. So it's trapped between negative 34 and positive 34, and 34 to both pieces, negative 30. Like that. Divide them both now. Gotcha. Now do this. Best check these two. Negative 3, 3.8. Negative 3 and a third, 2. Correct. Problem 15. Oh, it's greater than 11 this time, so you're not going to get me this time. So, how to procedurally solve this, though? How to do this right? That's one answer which comes from just solving it as if it were an ordinary one. Or 7 over negative 4. Negative 7 over 4. A is greater than negative 7 over 4. Right. How to do this, then? It'll click, I'm just not accustomed to these, that's all. Right, so first do that, then do that. Okay, so negative 8a equals 14. So a equals negative 14 over 8 or negative 7 over 4. Gotcha. Negative 8a equals negative 8. So a equals 1. So we know negative 7 over 4 and 1 will be involved. Like that. Hollow, please. Fair enough. Okay. But we start out with it having to exceed this quantity here. So I guess that's a signal that it should be outside of that. And then, of course, we just simply test a given number. So like I put 2 in there and I get -16, and -16 take 3 is -19. Absolute value is 19, and that is indeed greater than 11, so that passes. So 2 is good to go. -3, put that in there. -8 times -3 is 24. 24 take 3 is 21. Absolute value of 21 is greater than 11, so that passes. Then put in 0. 0 take 3, the absolute value of that is 3, and is 3 greater than 11? No. So 0 fails. Okay. I think I'm getting the hang of it now. Here, 1 take 4k, the absolute value of that must be greater than or equal to -11. So solve it as a linear. 1 take 4k equals 11. And then 1 take 4k equals -11. We do the first one. -4k equals 10. K equals 10 over -4. K equals -502. Got it. Now this one. -4k equals -12. K equals -12 over -4. K equals 3. Got it. And so -2.5 and 3 are our key points. And I believe it will be here, like this. And so to speed up testing, I'll just stick in 0. Is 1 greater than or equal to -11? It is. And so that should be included. 0 is like pass. So I do that. Right, I have to check these now. 15 and 16 look like that. All real numbers, huh? No way. I guess I really don't understand these things. Okay. Well, certainly that region there is included. Input 4. 1 take 16, absolute of that. Oh my goodness. I see it now. It's so obvious now. Instead of following the procedure, just thinking about what it actually means, the absolute value of something, and I'm claiming that that's greater than or equal to -11. Of course it is. That's always true. What a brilliant question. Okay. Getting the hang of this now. All right. Add 10 to both sides. You get 36. Divide both sides by 9. Absolute of m take 8 is less than 9. Okay. If m take 8 equals 9. No, wait. We already know how to do this. M take 8 is trapped between -9 and 9. You got 8. Okay, it's between -1 and 17 then. How frustrating. That's not actually on there. Oh my goodness me. Am I overtaxed? Potentially. 36 divided by 9 is 4. Okay. So M take 8 is trapped between -4 and 4 exclusively. At 8. There. Hollow dot under 4. Hollow dot. Check. No. Input 10. All right. 10 take 8 is 2. 9 times absolute 2 is 18. 18 take 10 is 8, and 8 is indeed less than 26. So I believe 17 is like that, between 4 and 12. Okay, it is. Okay, problem 18. Take 4 from both sides, so 45 on the right. So absolute of x at 8 is less than 5. So x at 8 is trapped between -5 and 5 exclusively. Take 8. Right. Now there. And there. 13 and -3. Here at 10. So less than -63. Divide. Less than -7. Okay, so we have the absolute value of something being less than -7. That's not possible. So I say no solutions. We'll see if I'm right. Good. Add 9 to both sides. 12 add 9 is 21. 21 over 7 is 3. So absolute of n over 3 is less than 3. So -3. It's trapped between -3 and 3. So it's trapped between -9 and 9. I believe. Hollow under -9. Hollow under +9. There. Okay, works. Add 1 to both sides. 74. 74 over 2, 37. 10b adds absolute of 10b adds 7 is greater than 37. Solve as a linear. Anyway, 30. So b is 3. And then set it equal to -37, and then 3 or -3. Okay. Like that. No. I believe it would be this. Check. Input 0. Is 7 greater than or equal to 37? No, it is not. So 0 is excluded. Now input -5. Yeah, same arithmetic. Fine. Okay. This one. 53. Solve as a linear. Just one moment. Anyway. (46/6). Come on. (46/6). So, I believe it's -10, 7 2/3, filled in dots. No, 0 included. Yeah. So check. Okay, that works. Here. Take 8. 6, divide by 4. Solve as a linear. Is 4 included? I mean, I think yes, but let's see. 6 take 8. Absolute, that's 2. 4. 51 take 6 is 45. 45 over 5. 45 over 9 is 5. Okay. Damn it. Okay. Oh, goodness me, I see it. Of course. No worries. I see. I see what went wrong there. Now over here, stick in 0. Okay, -2, absolute. That's 18. No, -2 absolute is 2, and then 9 times 2 is 18, and 18 add 6 is 24, and is 24 greater than 51? No, it is not. This is just fatigue. That's all it is. But for the others, yes. All right, last two. I'm going to turn on my lights. I'm aware that it's daylight outside, and I know that it would save power, but it hurts my eyes. So, take 3. Divide by 4. Then what? Oh, all of them. All numbers when you do the absolute value. Yes, it's all of them, indeed. Okay, last one. Get it right. 9 absolute 1 add a10 is greater than or equal to 81. Absolute of 1 add a10 is greater than or equal to 9. And when is that true? Solve as a linear. Maybe here. Okay. Input 0. False. It's everything else. Okay. Check. Hoorah. Did it. All right. I was successful. That's good. And now to get more. The next one. Oh. I can't do it when that's plugged in. Right. And I have to do an audio check. It will just randomly scroll because it gets confused about signals. Test. Test. Okay. Right, back to work. Solve each compound inequality and graph its solution. Okay, well, this one means equal to -2. No, -4. like that. Like that, I believe. All right. Awesome. Okay. This one says k is greater than or equal to 4. Or k is less than or equal to -3. Fill it in. Okay. What's to be done about this one? Okay. It's true that 4b at 18 is less than or equal to negative 12b take 14. And at the same time, it's true that negative 12b take 14 is less than or equal to 14 take 5b. So if I manipulate the left one and then the right one, and treat them separately, it will be hunky-dory. So that's how I believe it works. We have to check. There. Okay. That one. Okay, so A is greater than or equal to 0, and at the same time less than negative 1, no solution. Okay, come on. Now, one step. One step. Okay. Uh-oh. Try again. $11 on the right and P on the left. So P is less than or equal to 11. Fine. 2P on the left. Negative 6 on the right. P on the left. Negative 3 on the right. Okay. Don't understand it. Come on. Okay, I think both. Okay, this is just outright confusing me. I've got to see. Okay, so P is less than or equal to 11, and at the same time, P has to just be less than -3. All right, so it's just all of that. This sort of like encompasses all of those solutions. All right, I get it. This one, separate. Over here. Okay, so V is less than or equal to -3, and at the same time, V is greater than -13. So like that. Fine. Okay. That makes no sense at all. Taking 14 out from both pieces, we have 20 is less than 16, which doesn't make any sense. But it's nonsense or sense on the right. So if I can make sense of this, perhaps it's this. That's how it works. As long as one of them is sensible and true. If you've got a disjunction in the middle, it's fine. All right. So we have -7. And R is less than that. Last one. 7x on the right, 14 on the left. X on the right, 2 on the left. 2 is greater than or equal to x. -15 is less than or equal to 5. That's true. In fact, so I think it's actually all of them, because that one there is true. So all numbers. Like, it doesn't matter what number you stick in there, that's always going to be true, isn't it? Yes, okay. R is less than or equal to -7. All real numbers. Okay. Complete. All right. All right. I'm gonna check the sound and take a break for a brief drink of water. Okay. Testing. Okay, passes the sound check. And let's continue. Wait, let's just stretch legs beforehand. Okay, solve each inequality and graph its solution. Right, 0 is greater than 3x, take 9. So 9 is greater than 3x. So 3 is greater than x. Is that really it? 3 is greater than x. Perhaps I picked up the easy paper. No. It's just a nice start. All right. 4x add 1, take 1 is greater than or equal to negative x. So combine these cancel out. So x is greater than or equal to negative 2. That's solving the inequality. So put a filled in dot underneath negative 2 and branch to the right. Take 4 from both sides. Oh man, goodness, I thought that was compound inequality then. Yeah. Come on. One step in your head. One is too beautiful. I don't think I can really continue. Oh, try. Okay, try. Okay, sound check. And quick pause. Check. Okay, that works. Come on. I'm just gonna have a small piece of chocolates. Not endorsing anybody or promoting anything. Just trying to keep the energy for it. Okay, good so far. And now, okay, valid. Doing good. Okay, minus 6, 5. Minus 6, 5, minus 28 of 5, 6. Oh, darn. That's not actually true. That's correct. Come on. Oh, of course. Okay, that's finished. Right, there's no way I'm doing any more of this today. Be well, be well. Can't click off.